Okay, we're going to do some example unit analysis problems. Okay, in order to do unit analysis, we're going to follow these steps right here, which are to first identify the known and unknown, find the conversion factors that we need, remembering that a conversion factor is any equality written as a fraction. So, for example, if my conversion factor was 1 dozen donuts, 1 dozen equals 12. We'll say it's donuts. As a conversion factor, I would either have 1 dozen over 12 donuts or 12 donuts over 1 dozen. Those are the two conversions I could make using this equality. We use those conversion factors to set up a problem so that the units cancel, and then we'll solve. We'll multiply across the top and divide across the bottom. So let's see how this works out. Okay. If a car is traveling at 50 kilometers per hour, okay, there's my known. Is that above or below a speed limit of 40 miles per hour? Okay, so in this problem, my known is 50 kilometers per hour. My unknown is I want to know what that is in miles per hour. Okay, miles per hour is typically written like that. If you wanted to make it look more similar to that, we would rewrite it like this. Okay, so I know that I need to convert the kilometers to hours. I have that conversion factor right here. Pretty standard converting from English units to metric units. Sorry about that. We will be using that one. So let's set up our problem. Okay. We'll start with our known, which is 50 kilometers per 1 hour. Okay, that's 50 kilometers per hour. Now we need to write this equality as a fraction. So should I put the kilometers on top or bottom? I'm going to put the kilometers on bottom because I want the units to cancel. So there's 1.609 kilometers per 1 mile. When I do that, these kilometer units can cancel out with these kilometer units. And the units that I'm left with is miles over hour, which is exactly what I wanted. Okay, so we just solve it out. We have 50 times 1, which is 50 miles, over 1.609. The units we have left there is hours. We plug that into a calculator. 50 divided by 1.609, and I get my answer of 31.075 miles. Because this number only had 2 significant figures, I'm going to round my answer and make sure that only has 2 sig figs. So I'm going to say it's 31 miles per hour. Okay, so it is below a speed limit of 40 miles per hour. Okay, so there's one example. Let's look at a slightly more complicated example. Oops. How many kilometers are in a marathon? Okay, so this is a very similar problem, only this time instead of having a speed, a mile per hour, our known is just one number, 26.2 miles. My unknown is how many kilometers that is. So I'm going to be using that same conversion factor that I used last time. Okay, be using that same number. I start with my known, 26.2 miles. It doesn't have a per, it's not miles per hour or anything like that. So we just use it like that. Times. This time, I want the miles to cancel out. So I'm going to be putting 1 mile on the bottom. Sorry, here, let me keep this constant and I'll write it using the abbreviation. 1 mile on the bottom and 1.609 kilometers on top. Okay. Often, scientists, if you're doing a longer one of these, they got tired of reading times and then a line for all of it. So sometimes you will see it drawn like this. It means exactly the same thing. It's just a shorter way of writing it. So we do that. Miles and miles cancel out. I have 26.2 times 1.609, which gives me 42.1558. I'm going to round that to 2 sig figs, so I'm going to say 42.2 kilometers. Okay. If I wanted to know how many 5K races that is, well, okay, that didn't work out. If I wanted to know how many 5Ks that was, a 5K race is 5 kilometers. So I would take that 42.2 divided by 5. That means that if you wanted to run a marathon, that's 8.43 5K races. Okay. And that I just got by dividing this number by 5. Okay, let's look at one more example that requires more than one conversion factor. A cheetah runs at 28 meters per second. Okay, that's my known. What is this in miles per hour? That is my unknown. So this one, not only am I going to have to convert from meters to miles, I'm also going to have to convert from seconds to hour. So this is a much more complicated problem. Okay? Just so you guys can see how many conversion factors you can string together and still get the right answer, instead of looking up the conversion from miles to meters, I'm going to stick with this one of 1 mile equals 6.09 kilometers. I'm also going to have to go from kilometers to meters. So I know that 1 kilometer is 1,000 meters. Okay, that's something that you need to know. I'm also going to have to go from seconds to hour. So I don't know seconds to hour off the top of my head, but I do know that 1 minute is 60 seconds and 1 hour is 60 minutes. So that's 4 different conversion factors. This is not an easy problem, but I want to show you how the same techniques that we did in the other problems can be translated to this one. So I'm going to start with my known, which is 28 meters in 1 second. Okay, so 28 meters in 1 second, that is just this known right here. I'm going to go ahead and deal with the meters first. First, I need to convert the meters to kilometers because that's what I have to convert to miles. So I want the meters to cancel out. There are 1,000 meters in 1 kilometer. Okay. At that point, meters and meters would cancel out. I have how many kilometers per second it would take. Convert the kilometers to miles. There are 1.609 kilometers in 1 mile. Okay. Kilometers and kilometers cancel out. That'll give me my miles per second. But I want miles per hour. So let's deal with the seconds now. I'm going to convert the seconds to minute. Because the seconds is on the bottom, I need to put it on top to cancel out. So 60 seconds in 1 minute. Now these seconds here cancel out with these seconds here. I'm left with miles per minute. One more step. Minutes cancel out, so 60 minutes in 1 hour. Now the minutes and minutes cancel out. The units that I'm left with are miles over hour. So if I solve that out, I'm going to have 28 times 60 times 60, which gives me 100,800 over 1,000 times 1.609, which gives me 1,609. And again, the units on top are miles. The units on the bottom are hours, because that's what I'm left with. And then I divide that 100,800 divided by 1,609, and we get a speed of, we only had 2 digits here, so I'm rounding it, of 63 miles per hour. Okay. Remember, miles per hour, for some reason we tend to write it as miles per hour. It means exactly the same thing. Either way is fine. So a Cheeto runs at 63 miles per hour. And we got that by just following the steps and using the conversion factors. This is probably one of the more complicated ones that you'll see. Hopefully that made that a little clearer.